Alright, in this video session I'm simply going to be working out some problems that may appear in our next quiz. So this is kind of like extra practice. I'll write the problem, I'll wait for a second where you can pause it and try to work it out on your own, and then kind of compare your answer to mine or your work to mine. So let's see, let's say we have a problem like this one. I have 9 over 15 and we're multiplying it by 20 over 6. And multiplication of fractions, the most important thing you need to do is simplification. And to simplify, I need to break things down. So the 9, I can break that down into 3 times 3. The 15, I can break that down into 5 times 3. The 20, I can break that down to 4 times 5. And I can break this 4 into 2 times 2 as well. And I recommend you do that, but I know for this problem, based on what I see, I'm not going to need that. And 6 is 2 times 3. Once it's in this broken down form, all you need to do is cancel out any pairs that you see that are the same top and bottom. I see 3 here, 3 here, 3 here, 3 here, 5 here, 5 here, and nothing else. Actually, I should have broken down that 4 into 2 times 2. Because when I do that, I see something else I can cancel out. A 2 and a 2. So what's really left at the top is that 2 and nothing on the bottom. That's the answer. Let's do one where it's a multiplication of decimal numbers. So let's multiply 1.36 times 12.4. When you multiply decimals, what you want to do first is figure out how many numbers you have after the decimal in the problem. Here I have 1, 2. Here I have 1. So in total I have 3. So I have 3 numbers after the decimal. Then, once I have that written down, I pretend like the decimals don't exist and I multiply it as such. And you also want to figure out your signs ahead of time. But here I have positive times positive, multiplication with the same signs, always positive. So again, I'm pretending like I don't have any decimals, so I'm multiplying 136 by 124. I'm going to do my long multiplication here. Okay, so multiplication, 4 times 6, that's 24. 4 here, 2 in reserve. 4 times 3, that's 12. I have 2 in reserve, that's 14. So 1 in reserve. 4 times 1 is 4, so that's 5. 2 times 6 is 12. 2 times 3 is 6, that's 7. 2 times 1 is 2. 6, 3, 1. So unless I did my multiplication wrong, which is possible, this should be it. 5 plus 7, that's 12. 12, that's 18. So the answer should be 16864. Now, how many decimals did I owe the problem? I owe the problem 3 decimals right here, and I'm going to bring them back. 1, 2, 3. So my true answer is 16.864. Alright, let's do another problem. This one, let's do it with division of 2 fractions. Let's go with, let's see here, 18 over 25 divided by 15 over 9. Alright, excellent. The first thing I want to do is I want to convert the division into multiplication because we don't have good rules for division. And the way I do that is I literally flip the divisor, or the second number, only the second number, not the first, not the dividend, and I get 15 over 9. See, flipped. Or you can also multiply it by the reciprocal, because this is the reciprocal of this. Then I break it down. 18 is 2 times 9, and 9 is 3 times 3. 25 is 5 times 5. 15 is 5 times 3. Oops, sorry, paper slip. Okay. And 9 is 3 times 3. Alright, let's get to canceling. 2. Ooh, that was premature. That 2 actually stays, but 2 does not cancel, because I have no 2's on the bottom. 3 with 3, 3 with 3, 5 with 5, and that's it. And that 2 actually stays. So at the top I have this 2 that never got cancelled, times 3. On the bottom I have just a 5. 6 over 5. Alright, let's go ahead and work out a problem where we're, let's see, dividing with decimals. Or actually, let's do one where we're dividing with an improper fraction. So for example, let's have 3 and 2/3 negative. Divide that by 2, and let's see, what can we do? 5 over 6. My first step here is to convert my mixed numbers into non-mixed numbers. And I'm going to do that. 3 times 3 is 9. 9 plus 2 is 11, so negative 11 over 3. 2 times 6 is 12, plus 5 is 17. Alright. Then my next step is to flip the divisor in order for me to be able to convert the division into multiplication. So I'm going to literally flip this on its head. Then I'm going to see if I can cancel anything out, and I can. I can cancel out the 3's and nothing else. But that's still not bad, because now I don't have to multiply anything. The only thing left on the top is a negative 11, on the bottom 17, and that's my answer. Alrighty. Let's do another problem. This one, let's go ahead and do division with decimals. Let's see here. Give me a second. Right, let's try that problem out. Division with decimals. Unlike multiplication with decimals, we don't have to worry about remembering how many numbers are after the decimal. The only thing we need to do is to get both the divisor and the dividend to be whole numbers. I'm going to work on this one first because it has more numbers after the decimal. So I need to move the decimal over twice in order to make this into a whole number. Essentially the same as multiplying it by 100. And whatever I do to one part of the division, I have to do to the other part as well. So if I move the decimal over twice here, I have to move the decimal twice here as well. That yields 372, and that is 0 here, divided by 12. And the great thing is that that's it. I'm done. I don't have to worry about anything else as far as decimals go. Now I just do a long division problem. That's 3. 1 comes down, 2. That's 1. And I have a 0 here. So 310 is my answer. Again, once you get to the long division part, it should be fairly easy. The challenge, if there is one, is getting your decimals to be whole numbers. So again, hopefully this was helpful as an extra tool. The last thing I want to do is work on just breaking some numbers down, because a few of you do have some problems as far as breaking numbers for both the multiplication and the division with fractions. Let's say I have the number 27. I can break 27 down into 3 times 9. I can break